Einstein might be wrong. All hell broke loose in the physics community. Every physicist I know is taking a position on this hot topic because relativity is the foundation of modern physics, along with the quantum theory.
Prepare to be captivated by the ever-evolving tapestry of scientific discovery as we delve into the top 10 most famous scientific theories that turned out to be wrong. From ancient wisdom to modern marvels, these once-revered theories took unexpected turns, revealing the dynamic nature of our quest for understanding. Get ready for a mind-bending journey that will challenge your perceptions and leave you hungry for the full revelation. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space, and beyond, consider subscribing. 10. The expanding Earth. The concept of the expanding Earth, predating the widely accepted plate tectonics theory, suggested that the Earth's growth in volume was responsible for phenomena such as underwater mountain ranges and continental drift. Advocates of this hypothesis argued that as the Earth expanded, distances between continents would increase, leading to the formation of new mountains. This theory, with a history dating back to Darwin and Nikola Tesla, suggested a continuous growth akin to the expansion of a dying star. Although the expanding Earth hypothesis has not been definitively disproven, it has largely been supplanted by the more intricate and comprehensive theory of plate tectonics. While the expanding Earth theory posited that all land masses were once connected and oceans and mountains formed due to the planet's expanding volume, plate tectonics explains these phenomena through the movement and convergence of plates in the lithosphere beneath the Earth's surface. 9. Spontaneous generation. While it may appear absurd in contemporary times, there was a prevailing belief for millennia that life could originate regularly from basic elements without the need for a seed, egg, or conventional reproductive methods. Aristotle, influenced by thinkers Hippolytus and Anaxagoras, championed this theory, emphasizing the spontaneous emergence of life from inanimate substances like slime, mud, and earth when exposed to sunlight. Aristotle derived his concepts from observations such as maggots seemingly generating from decaying animal carcasses or barnacles forming on the hulls of boats. This notion persisted for centuries beyond Aristotle and even found support from some scientists in the 1700s. The downfall of the theory came with the advent of the scientific method, which subjected classical ideas like spontaneous generation to rigorous testing. With this scrutiny, these notions swiftly crumbled. For instance, the renowned scientist Louis Pasteur demonstrated that maggots did not appear on meat stored in a sealed container. The invention of the microscope further revealed that these insects were not products of spontaneous generation, but rather originated from airborne microorganisms. 8. The unveiling of Vulcan. In the 1800s, scientists were convinced there was a planet called Vulcan between Mercury and the Sun. Urbain Joseph Leverrier, a mathematician, came up with this idea to explain strange things happening in Mercury's orbit. Leverrier and others thought an unseen force, maybe a small planet, was causing these oddities. They named it Vulcan, inspired by the Roman god of fire. Amateur astronomers in Europe eagerly helped, reporting sightings of Vulcan to Leverrier. People worldwide kept reporting sightings for years, even after Leverrier passed away in 1877. He was celebrated as the discoverer of a new planet, but doubt grew among astronomers, especially without Leverrier's support. The search ended in 1915 with Einstein's general relativity theory explaining Mercury's orbit. Although the scientific quest stopped, amateur astronomers continued searching. As late as 1970, some claimed to see a mysterious object orbiting the Sun beyond Mercury. Interestingly, the lasting impact of this failed discovery is its influence on naming Spock's home planet in Star Trek. 7. The Martian Canals. The Martian Canals, a network of gullies and ravines erroneously believed to exist on the Red Planet by 19th-century scientists, were first discovered in 1877 by Italian astronomer Giovanni Schiaparelli. Subsequent support from other astronomers turned the canals into a widely discussed phenomenon, with scientists creating detailed maps and engaging in speculative discussions about their possible origins and purpose. One particularly outlandish theory was proposed by mathematician and astronomer Percival Lowell, who suggested that the canals constituted a sophisticated irrigation system created by an unknown intelligent species. Although widely discredited by some scientists, Lowell's hypothesis gained popularity and lingered in certain circles well into the 20th century. The demise of the Martian canal myth came unremarkably with advancements in telescopes and imaging technology. The purported canals were revealed to be an optical illusion caused by streaks of dust blown across the Martian surface by strong winds. While similar theories had been proposed in the early 1900s, conclusive proof emerged in the 1960s when the first unmanned spacecraft conducted flybys over Mars, capturing images of its surface. 6. Luminiferous ether. The luminiferous ether, also known as the ether, was once believed to be a mysterious substance that carried light across the universe. This idea, present from ancient Greek times to the 19th century, suggested that light needed something to travel through to become visible. If true, this theory could have completely changed how we understand physics. Specifically, if ether was a real substance that could exist even in empty space, it could help us measure and understand deep space more accurately. Despite some contradictions in experiments by the 1700s, many people strongly believed in ether's existence. Physicist Albert Michelson called luminiferous ether one of the grandest generalizations in modern science, but eventually the idea was abandoned. This happened as more advanced theories became widely accepted and transformed the foundations of physics. Although the concept of luminiferous ether is mostly dismissed now, some argue that modern scientists still use terms like fields and fabric instead of the older term ether. 5. Blank state theory. The blank slate theory, also called tabula rasa, is one of the oldest and most debated ideas in psychology and philosophy. It suggests that when people are born, they have no built-in personality traits or tendencies. This theory goes way back, starting with Aristotle and supported by thinkers like St. Thomas Aquinas and John Locke. They argued that everything in our minds is shaped only by our experiences and education, not by instincts or nature. Sigmund Freud, a famous psychologist, also believed this, saying that our early childhood experiences shape who we become. However, this theory was eventually challenged and proven wrong. Now we know that our genes, family traits we inherit from birth, and some natural instincts also play big roles in shaping our personalities. We learned this from studying similar gestures and language features across different cultures worldwide. Research on adopted children and twins raised in different families also showed that certain traits are present from birth. 4. Phlogiston theory. Phlogiston theory, originating in 1667 through the work of Johann Joachim Becher, posits that all combustible objects, those prone to catching fire, contain a unique element called phlogiston. According to this theory, phlogiston is released during the process of burning, facilitating combustion. In its conventional depiction, phlogiston is described as lacking color, taste, or odor, and becomes perceptible only when a flammable object, such as a tree or a pile of leaves, ignites. After burning, the object is believed to revert to its true form, termed a calx. Beyond explaining basic combustion, the theory aimed to elucidate chemical phenomena and even contributed to understanding processes such as breathing, where pure oxygen was referred to as dephlogistated air. However, the theory faced increasing skepticism as experiments using the phlogiston model accumulated. Notably, certain metals were observed to gain weight when burned, contrary to the expected weight loss if phlogiston were being released. This inconsistency led to the decline of the phlogiston theory, eventually replaced by more advanced concepts such as oxidation. 3. Einstein's static universe. Before scientists widely accepted the idea of the Big Bang creating the universe, many believed in Einstein's static universe. This theory proposed that the universe's size was always constant. It never changed. According to this idea, the total volume of the universe was fixed, and it operated like a closed system. Albert Einstein, a famous scientist, supported this theory and included it in his general relativity calculations. However, this static universe theory faced challenges. A finite universe could become so dense that it might collapse into a massive black hole. Einstein tried to address this with his cosmological constant. The theory suffered its final blow when Edwin Hubble discovered the relationship between redshift, changes in color as objects move away, and distance, showing that the universe was indeed expanding. Einstein then abandoned his static model, later calling it the biggest blunder of his career. While most scientists accept the expanding universe idea today, a small group still holds on to the old static model, as cosmological ideas are still theories. 2. Phrenology. Phrenology, though now seen as a false science, used to be a popular branch of neuroscience. Simply put, phrenologists believed that specific character traits like intelligence or aggression could be pinpointed to certain parts of the brain. They thought that the larger these brain parts were, the more likely a person would behave in a certain way. To figure this out, practitioners studied the size and shape of people's heads, creating detailed maps of 27 supposed brain areas. For example, a person with a big bump on the skull area linked to the sense of colors might be assumed to enjoy painting. However, as science advanced, phrenology was proven wrong. Even in its peak in the 1800s, many mainstream scientists criticized it as quackery. It wasn't until the 1900s that modern science showed personality traits couldn't be traced to specific brain areas as precisely as phrenology claimed. Today, phrenology is considered a fringe science. Unfortunately, in the 20th century, it was misused to promote racism, notably by the Nazis and Belgian colonialists in Rwanda. 1. Fleischmann and Pons's cold fusion. Creating nuclear energy typically requires extremely high temperatures like those found in the processes that power the sun. However, the idea of cold fusion suggests that this nuclear reaction could happen at room temperature. It's a simple idea, but if true, it could mean generating a lot of energy without the harmful waste produced by traditional nuclear power plants. In 1989, electrochemists Martin Fleischmann and Stanley Pons claimed they achieved cold fusion in an experiment where they passed an electric current through seawater and a metal called palladium. This created excitement as it promised a new, clean, and abundant energy source. However, the enthusiasm quickly faded when other scientists tried to replicate the experiment without success. Fleischmann and Pons were criticized for flawed and possibly misleading results, leading cold fusion to be seen as fringe science. Despite the initial setback, some scientists are revisiting the idea of cold fusion. In recent years, they've been experimenting with new ways to achieve a tabletop nuclear reaction, with some claiming surprising success.